Hello and Tashidalek to everyone. So today we will be continuing with the topic of principal branch which we were discussing in the last class. Okay, so we were doing the second chapter, which is inverse trigonometric function. Okay, and in the last class we had discussed about the 6 inverse trigonometric functions, and I had given the domain and principal branch of 3 inverse trigonometric function, and for the remaining 3 I had asked you as assignment to complete that. Okay, so first I will quickly write down what principal values we have for each inverse trigonometric functions. Okay, so first one we have is sine inverse, and we had seen that the domain of sine inverse is close interval -1 to 1, and its principal branch is close interval -π/2 to π/2. So this is the domain of sine inverse and this is the principal branch of sine inverse, and we had seen in detail how we got this as a principal branch. So I had explained to you that in detail. Okay, and then we have cos inverse. Its domain is same, close interval -1 to 1, and its range is, or the principal branch is, close interval 0 to pi. Okay, then we have tan inverse, of which its domain is set of all real numbers, and its principal branch is open interval -π/2 to positive π/2. Okay, now here we have 2 separate brackets, so you have to be careful with the brackets. So in class 11 you had studied about the subintervals of real number, which we take it in 4 different brackets. Okay, so close interval, when we use close interval, it means within -π/2 to positive π/2 you have to take all real numbers, and you have to include -π/2 and positive π/2. That is close interval. So close intervals means you have to include the 2 extreme points with the values. Okay, when we take open interval, then we are taking all the real numbers in between -π/2 to positive π/2, excluding these 2 extreme points. You have to exclude these 2 points. So that is the difference between close interval and open interval. So you have to be careful with the brackets when you are writing. Okay, and then we have, now for these 3 we had together discussed, and the 3 I had asked you to do as assignment, and I hope you got the correct answer. So I'll give you here. So sine in, okay, then we have cosec inverse. Cosec inverse, its domain is set of all real numbers, excluding open interval -1 to 1. Now this is the domain of, this is the range of cosec, which becomes the domain of cosec inverse, because cosec and cosec inverse, in these 2 we have to interchange the domain and range. Okay, this imply this cosec inverse is from this set to. Now cosec inverse means it is the reciprocal of sine inverse. What is the relationship between sine and cosec? They are reciprocal of each other. So similarly, sine inverse and cosec inverse are reciprocal of each other. So we have this is close interval -π/2 to π/2, but we know that cosec, the value of cosec never lies between this, which means cosec is not defined at 0. 0, it comes in this interval, right? So therefore we have to exclude 0. 0 comes in this interval, so we have to exclude. Okay, then we have sec inverse. Sec inverse, it is reciprocal of cos inverse. So the domain of sec inverse is same as cosec inverse, that is set of all real numbers, excluding open interval -1 to 1, and it is defined as close interval 0 to pi. We know that sec is not defined at π/2. Sec means it is 1 upon cos. Cos is not defined at 90, so π/2. So we have to exclude π/2 here. So we will exclude π/2. Okay. Now why we are taking this bracket? Because it is the bracket for set. We are listing out the element. Okay. So here we are excluding only 0. Here we are excluding only π/2. So this is the bracket we use for set. Okay. So you cannot use other bracket for writing these 2 elements. And then we have tan inverse. Tan inverse, it is from, sorry, not tan inverse, cot inverse. Tan inverse we had already written here. Next is cot inverse. Now cot is the reciprocal of tan, so that is set of all real numbers to open interval 0 to pi, cot. Okay, so these are the 6 inverse trigonometric function with its domain and the principal branch. So these are the principal branch of the 6 inverse trigonometric functions. So please note down this in your notebook, because we frequently have to use this principal branch when we are solving questions. Okay. Now today we are going to we are not going to discuss any new topic. We will be solving few questions related to this concept or this formula, that is the principal branch. Okay, so I will give you few questions. Okay, first we'll take one example. Okay, if I give you this, find the principal value of sine inverse of half. Okay, find the principal value of sine inverse of half. Okay, now before coming to this question, first I will explain. Let me take a function f which is from set A to B. I have a function f which is from set A to B. Okay, then what do we have? If I take any element in set A, I get an image here in set B, which we denote it by, it is under function f. So we write f of x. You remember? So when we write f of x, it means it is the image of x, okay, under function f, is it? So now here my function is sine inverse. So okay, now you just keep it like this. Okay, I'll take it here. Now here my function is sine inverse, okay, and it is from, now sine inverse means your domain is close interval -1 to 1, and its principal branch is -pi/2 to pi/2, right? Now if I take any element in this set, see if I take x here in this set, then I will get an image here. That image I will denote it by sine inverse of x. When my function is f, then I write image of x under function f. Here my function is sine inverse, so therefore I will write image of x under function sine inverse. So here we write sine inverse of x. So you will get certain value for this sine inverse of x. So you will get a value, and you will see that since my principal branch is close interval -pi/2 to pi/2, this value, whatever you get here, that value will be always in between -pi/2 to +pi/2, which is called as the principal value. Okay, principal value. Principal value means that value of the inverse trigonometric function which lies in the principal branch. Okay, and this x, it has to come from this interval. It has to be from the close interval -1 to 1. You cannot take x outside this bracket. You cannot take that. So x is defined only within this interval, and for such x you will get a value here. That value will always lie within the principal branch. Okay, so first you understand this. So when I take function f, we used to write image of x under function f. So similarly here my function is sine inverse, so therefore I can write image of x under function sine inverse. Okay, now here I have, this is sine inverse of half, which means you take element half here in this set. Now half, it is in the interval -1 to +1. It is correct. Now you have to find its image, that is sine inverse of half. You have to find out this. Okay, so whatever value you get here, it has to be in between -pi/2 to +pi/2. So this is what we are asked to find out here, sine inverse of half. Okay, so this value will lie between close interval -pi/2 to +pi/2. Okay, so this is the first, you should understand what actually you are finding out here. Okay, now we'll come to the solution. In mathematics, to solve a question, there is always more than one method. In different books, you will find different methods, okay, done by the authors. So but you have to stick to one method, whichever method you are comfortable with, just stick to that method, okay? Because when you use more than one method, okay, so then you'll get confused. So whatever method you are comfortable with, just stick to that method, okay? So similarly, to find the principal value, there are different ways to find out, but what I feel the easiest one is, so I used to write it like this, okay? So since I have to find out this value, I will write let y is equals to sine inverse of half. So I have to find out y. We are asked to find out y. And you are asked here to find out the principal value, which means you have to know the principal branch of sine inverse, which is, or you just write it on the rough side, that is close interval negative pi by 2 to pi by 2. Okay, so whatever value you get for y, it should be within this interval. So you have to remember that, okay? Now what I will do is, this is sine inverse. When I take this on the left hand side, okay, sine inverse, you take the inverse of that. So sine inverse and sine, they are inverse of each other. So when I bring it over here on the left hand side, sine inverse becomes sine. So I can write sine of y, this is equals to half. Actually, this is not the correct way to say that when I bring it here, it becomes sine. But just for the time being, you just try to understand in this way only, okay? Otherwise, later on in the next section, we have to derive one formula from which you will get this, right? But right now, since you are not familiar with that formula, so you will just consider this. When you have a sine inverse on right hand side, and when you transpose it on the other side, sine inverse will become sine. So in that way, you can just try to understand at this time, okay? So we get sine y is equals to half. We are taking this here, so we get sine y, that is equals to half, this half, okay? Now my left hand side is in terms of trigonometric ratio sine, okay? So therefore, I will try to express right hand side in terms of sine. Why am I expressing right hand side in terms of sine? Because my left hand side is in terms of sine. So now I will write sine y is equals to, now half means if you want to express that in terms of sine, so sine 30, okay? Sine 30 is half, right? So therefore I will write sine. Now here we are only taking the angle in terms of radian, so I will not write sine 30. So I will write the angle in terms of radian, so I will write sine pi by 6, okay? So also you can, some of you may think half can be expressed in terms of cos also. Cos 60 is half. But we are not taking cos because my left hand side is in terms of sine. So therefore I am expressing half in terms of sine, okay? Now you look here. This is sine, this is, so these two you can cancel. So y is equals to pi by 6. First you will not directly write y is equals to pi by 6. First you check whether pi by 6 come in this interval or not, okay? So we get y is equals to pi by 6, which belongs to close interval negative pi by 2 to pi by 2. It lies within this interval, okay? So therefore you will write, what is y? It is sine inverse of half is equals to pi by 6. So this is what you are asked to find out, okay? So we got a value of sine inverse of half, which is equals to pi by 6. And now this is the principal value, okay? You can see that this lies within this interval. So this is the required principal value for sine inverse of half. So in this way you have to do, okay? So now we'll take one more question. Okay, now we will take a second example. Okay, find the value of tan inverse of -1. Okay, now we'll try to solve this together, okay? Now it's all same. The way I've solved this example, in the same way I'm going to solve this also. So first I'll write let y is equals to tan inverse of -1. Now you should know the principal value. Okay, now one thing. Here in the first example, you are specified that you have to find the principal value, which means the value you get here, it should lie within the principal branch, okay? Even if it is not specified, you're just asked here to find the value of this inverse trigonometric function. Here also you have to find the principal value, okay? So whether it is specified or not, you have to always find the principal value, okay? So now here the inverse trigonometric function you are given is tan inverse, of which the principal branch is open interval negative pi by 2 to pi by 2, right? So we should get a value which is in this interval, negative pi by 2 to positive pi by 2, okay? So now I will write here, now this tan inverse, I'll bring it over here, so I get tan y is equals to negative 1, okay? Since the left hand side is in terms of 10, I will try to express right hand side in terms of 10, okay? So I write tan y is equals to negative, you keep it as it is, 1 you just try to express it in terms of 10, okay? So 1 means 10 45, so that is 10. Now I will not write 45, I will write the angle in terms of radian. That is the standard way of writing, since our all the principal branches we have taken in radian form. So therefore I will write here 10 pi by 4, okay? Okay, now just stop here. I will explain a little concept of class 11 over here. I'm going to use it here. Okay, in class 11 you might have studied what is even function and what is odd function. So we have a small concept, that is even and odd function. So the function, okay, we have this sine of negative x is negative sine x, cos of negative x is, oh sorry, tan of negative x is negative tan x, cosec of negative x is negative cosec x. So these three functions, sine, tan and cosec, when you take the negative angle, you get whole negative value. So these three are examples of even function, okay? Then we have cos of negative x is equals to cos x, and then we have sec of negative x is sec x, and cot of negative x is cot x. So these three are examples of even function, and these three are examples of odd function, okay? So the six trigonometric ratios can be categorized as even function and odd function. So these three are even and these three are odd, okay? So now you look here, when you have negative tan of negative x, so then this is equals to negative 10x, okay? So now here I have negative 10 pi by 4, which means this negative I have to take it with angle. So this negative, it is taken with the angle, so I have to do it here. So that is tan y is equals to tan of negative pi by 4. You have to take this negative inside, so you get tan of negative pi by 4. So I have now 10 will get cancelled, but you will not cancel it out, just assume you are cancelling out these two. So you get y is equals to negative pi by 4, right, which lies in the principal branch, that is negative pi by 2 to pi by 2. This is negative 45, this is negative 90 to positive 90. So it means this is in this interval, okay? So therefore we have tan inverse of negative 1 is equals to negative pi by 4. This is the required principal value, or the value of tan inverse of negative 1, okay? So now these are the concepts you had learned in class 11, so we are just using it here. So when you have a negative of 10, okay, negative of 10, then this negative, it is to be taken with the angle. So I'm taking directly this negative inside with the angle, so I get tan of negative pi by 4. Now tan, so you can cancel it out. So we have y is equals to negative pi by 4, which lies in the principal branch. So this is the required principal value, okay? So this is how we will do. Now we'll take another example. Okay, example 3. Okay, I'll write it here. Okay, find the value of example 3. Find the value of cos inverse of negative half, okay? Now you start like this, let y is equals to cos inverse of negative half. So you have to find the principal value of cos inverse, for which you need the principal branch of cos inverse, which is, you just write it in a rough side. Okay, so that is closed interval 0 to pi. If you know that, you don't have to write it. Okay, so I'm just, and for your understanding, I'm writing this. So now we have to find the value of y such that it lies in this interval. Okay, now you bring it over here, so we get cos y is equals to -half. Since my left hand side is in terms of cos, I will try to express my right hand side in terms of cos. So that is cos y is equals to negative. First you keep it as it is, then you take half. Half, try to express it in terms of cos. So we have cos 60 is equals to half. So I will write cos pi by 3. Okay. Now you look here. When you have negative of cos, you cannot take this negative inside because we have this here. Cos of negative, when you take cos of negative, this is positive cos x we get. We have negative here. So suppose if I take this negative inside, then what do I get? I get cos of negative pi by 3, right? But using that formula, what do I have? Cos of negative pi by 3 is cos pi by 3, is it? But here we have minus cot pi by 3. So therefore, for cos, you cannot take this negative inside, okay? So similarly for sec and cot, when you have negative outside, you cannot take this negative together with the angle. This can be done only for these three ratios, sine, tan and cosec. In the previous example, we had seen for tan. But when we have negative cos, so then you cannot take this negative inside. So now what we are going to do? Now here we will be using one more concept of class 11, okay, which is, first is I'll show it here, okay. I'll try to show you in the Cartesian plane. Okay, in the quadrants we have 0 to pi by 2, first quadrant, second quadrant pi by 2 to pi, third quadrant pi to 3 pi by 2, and fourth quadrant it is 2 pi. Okay, now we know this behaviors of the 6 trigonometric ratios in each quadrant. So we used to write it like that: add sugar to coffee. Your teacher must have introduced like this. Okay, add sugar to coffee. So A is for all. In the first quadrant, this is first quadrant, right? In first quadrant, all the 6 trigonometric ratios are positive. Okay, so if your angle is 0 to 90, first quadrant means 0 to pi by 2, within this, all the 6 trigonometric ratios will be positive, okay? In the second quadrant, when the angle is pi by 2 to pi, when your angle is this angle, when the value of y, and when the angle is pi by 2 to pi, this is the second quadrant. In second quadrant, sine and its reciprocal cosec are positive. Rest 4 trigonometric functions are negative. Okay, so sine and cosec are positive. So cos, sec, tan, cot, all these 4 are negative. Okay, so when the angle is in between 90 to 180, the positive values you will get for sine and cosec. For the other 4 trigonometric ratios, you will get negative. For example, if I write the tan of 150, right? So 150 means it is in this interval. This is 90 to 180. So tan of 150 means you will get some negative value over here, is it? So similarly, if I write cosec of 150, 150 means which is in this interval. In second interval, cosec is positive. So whatever value you will get a positive value over here. So this is what I mean to say, okay? So in second quadrant, sine and cosec are positive, rest 4 are negative. Okay, in third quadrant, okay, add sugar, this is 2, right? Tan and cot, it's reciprocal. These 2 are positive, rest 4 are negative. Okay, so suppose say if I write tan of 230, right? So tan of 230, this is 180 to 270. So 230, it comes in this interval. So when you take tan of angle 230, you will get a positive value, right? Because in this quadrant, tan is positive. Okay. If I write cosec of 190, 190 again it is in this interval 180 to 270. So cosec is negative in this interval. So you will get a negative value for cosec. So like this we can define. Okay. In the fourth quadrant, this is fourth quadrant. In the fourth quadrant, cos and its reciprocal sec are positive, rest are negative. Rest 4 are negative. So these are the behaviors of the trigonometric ratios in the four quadrants. Okay, now look here. Cos of negative half. Cos of angle y is negative half, which means for some value of y, where y is the angle, you are getting a negative value. So now we have two options. In first quadrant, cos is positive. In fourth quadrant, cos is positive. So this means this y, either it lies in second quadrant or it lies in third quadrant, because we know that we are getting a negative value here. So if it is negative, then this y, either it is in second quadrant in which cos is negative, or it is in third quadrant again in which cos is negative. Okay, now you have to take this concept together with the principal branch, because here we are finding out the principal value. Okay, so now this interval 0 to pi means 0 to pi means first and second quadrant. So y, there is no possibility that y will lie in first quadrant, because in first quadrant cos is positive, but here we got a negative value. So now you can divide this into two, that is 0 to pi by 2, first quadrant, and second quadrant, pi by 2 to pi. You have two quadrants, right? In this, y will not lie because we get a negative value here. So the possibility is here. Now here we have two possibilities. Either y will lie here or here. Okay, so now y will not lie in this interval because we need to find y in the principal branch. So now we are left with only one option, that is y has to lie in the second quadrant, that is pi by 2 to pi. Is that clear? Now what I'm going to do is here, now we need to apply one more formula of class 11. You remember this? Cos of pi minus theta is negative cos theta, where theta, there is a restriction on theta. Theta is less than pi by 2. Okay, 0 is less than or equals to, theta is less than or equals to pi by 2. So when I subtract theta, which is less than 90, greater than 0, when you subtract theta from pi by 2, this angle, it enters in second quadrant. Here this is pi by 2, and this is 0, this is 3 pi by 2. Okay, now when I write pi minus theta, I'm entering in this quadrant, second quadrant. Is it? In which cos is second quadrant? Pi minus theta. So where you are subtracting theta from pi, where theta is less than 90. So your angle, this term, will lie in this interval. In second quadrant, cos is negative, so therefore we are getting a negative value over here. Are you clear with that? So therefore I can write here cos y is equals to, now we cannot take this negative inside as I've shown you here. So now I can write cos of pi minus theta is here, pi by 3. So now we got this formula. Cos of pi minus theta is equals to negative cos theta. So here I'm going this way. I have negative cos pi by 3, which can be expressed as cos of pi minus pi by 3, because we are getting a negative value since this angle, it lies in second quadrants in which cos is negative. So you can write it like this. Okay, so therefore now I have cos y is equals to cos of 3. Okay, now you can solve this. So that is 2 pi by 3. Okay, so we have now y is equals to 2 pi by 3, which lies in 0 to pi. Okay, so therefore we have cos inverse of negative half is equals to 2 pi by 3, which is the principal value. Is that clear? Okay, now I'll just summarize it here for this all these formulas. Okay, you can note down, because we need to use this frequently in this type of question. So you just note down, you may forget. Okay, if you have negative sine x, negative tan x, and negative cosec x, in case if you have this, so then you will directly take negative inside. So that is tan of negative x, cosec of negative x. In this way you will directly take negative inside. Okay, and these three you can categorize as one case. If you have negative cos x, right? Negative cos, then you will not take negative inside. In that case, what you will do, cos of pi minus x you will write, okay? Similarly, if you have negative sec x, then you will write sec of pi minus x. You will not write sec of this negative, you will not take it with that, okay? Then similarly for cot, negative cot x, cot of pi minus x. So please you note down all these things somewhere in your notebook, because you have to apply this frequently in such type of question, okay? So when you have sine, tan and cosec, group them, okay? Sine, tan and cosec, you have negative sine x, negative tan x, negative cosec x. Then in these three cases, you can take negative directly with the angle. Whereas if you have negative cos x, negative sec x, negative cot x, then you cannot take negative with the angle, okay? So what you will do, you will take cos of pi minus x, sec of pi minus x, cot of pi minus x, okay? It will directly take you in the principal branch, okay? So this is how you will remember, okay? Now I will take one last example, okay? One more question I'm going to do which will clarify all these concepts. Okay, fourth one. Okay, now we will do this. Now the concept is same, okay? In all this you have to find the principal value, right? But we are taking the sum of three inverse trigonometric functions. So separately you will not do. Together we will try to solve. So this is equals to, now you look here. In the first term, the outside term, it is in sine inverse. So therefore inside the bracket term, we will try to express it in terms of sine. It is sine inverse, so we will try to express it in terms of sine. Here we have tan inverse, so we will try to express this in terms of tan. Here we have cos inverse, so therefore we will try to express this in terms of cos, okay? So now I have sine inverse is equals to 1. You will try to express it in terms of sine. So that is sine 90 is equals to 1. So I can write sine pi by 2, right? Plus tan inverse of negative, you just keep it as it is. 1, you'll try to express it in terms of 10, because we have here tan inverse, so this term it is to be expressed in terms of 10. So 1 in terms of 10, it is 1045. So I will write 10 pi by 4, right? Plus cos inverse, so therefore we will try to express this in terms of cos, okay? So negative, you just keep it as it is. Root 3 by 2, what is it? It is cos 30. So I will write cos pi by 6. Please write angle in terms of radian always, okay? So now you can cancel these two. Sine inverse and sine will get cancelled, so you write pi by 2, okay? Plus, here you cannot cancel tan inverse and tan because we have negative. So first you have to solve this negative. So we know that now in the earlier I had written, when you have negative 10, then directly you can take negative here. So I can write tan inverse of 10 of negative pi by 4. When it is 10, then you can take negative with the angle. Similarly for sine and cosec, when you have negative, that you can take it with angle. So I'm doing it here. This negative, I'm taking it with the angle, okay? Plus, similarly, you cannot cancel these two because we have negative over here. So first we need to solve this. So I will write cos inverse of. Now, when you have cos, then you will not take this negative with the angle. Okay, you remember I'd written that. So what you will do, you will write cos of pi minus pi by 6. Is that clear? Okay. So now we have pi by 2 plus, now you can cancel these two. So here we have negative pi by 4 plus these two you can cancel. So we have pi minus pi by 6. So now we have to solve this. Plus minus minus pi by 4 okay, plus 6. There is 5 pi by 6. Now you have to solve this. So pi by 2 minus pi by 4 is pi by 4 plus 5 pi by 6, which is equals to 6, 12. So 3, okay, 6 2 is 12, 10, 10 plus 3, 13 pi by 12. Okay, so this is how you will solve it. Okay, now since it is the sum of few inverse trigonometric ratios, the value need not lie in any principal branch. It can be any value. Okay, but separately for each of this you have to find its principal branch, principal value. Sorry, this lies in the principal value, this lies in the principal value, and this lies in the principal value. Okay, so you can see sine inverse of 1 is equals to pi by 2, which lies in the principal branch. Tan inverse of negative 1 is negative pi by 4, which again lies in the principal branch. Cos inverse of negative root 3 by 2 is 5 pi by 6, which lies in the interval 0 to pi. Okay, so separately they all lie in the principal branch, but together it need not lie in any principal branch. Okay, so with these 4 examples, I hope you are clear with the concept of how to find principal branch. Okay, so for this type of questions, you need to know obviously the principal branch of the 6 inverse trigonometric ratios, plus you are needing this formula of class 11. Okay, now in class 11 in the chapter of trigonometric functions, there are more than so many trigonometric functions formula you have. Okay, so we are using all this formula in this chapter, plus we have some more formula in this chapter. So basically for trigonometric functions there are so many formula, so memorizing the formula is not the correct way to learn the formula. Okay, so to learn the formula you need to practice them in questions. So as many practice you make, the more you will be clear with the formula, and in each formula you will see certain patterns. So you need not to memorize this formula. Okay, so you don't need to memorize this formula. So keep practicing. Okay, keep practicing, so you will automatically learn all the formulas. You don't have to memorize. Okay, so with this I will stop here. And for today's assignment, okay, so you will note all the formulas which I had written here. First you make a note on the domain and principal branch of the 6 inverse trigonometric functions, like formula, because we are needing all these things. Okay, and then you note down, make the note of the formulas which I had given here of class 11, and after that you will do this assignment of textbook exercise 2.1. okay, it's a very small exercise. You have only few questions in that, and all the questions are on the topic principal branch. So I think you can easily do. I had solved almost all types of question here. Okay, so you won't face problem doing this exercise. So this is your assignment. Okay, so I'll see you in the next class. Thank you.